Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 1.5. As in the previous lecture, you may have noticed that we had only done till question number 3, and the main objective of today's video is to complete the whole exercise today. Okay, so the first question, let's start. We have question 4, which is that we have been given the domain for -3 to 4. Yes. So we have been given the domain for -3 to 4. Okay. For what were the domains? You may remember from the exercise 1.1. Domain is the set of input values, while the range are the set of output values. Okay. So if you don't understand these two terms clearly, you can anytime go to exercise 1.1. I have a lecture about that, and it's explained clearly in that lecture. So the thing is, for now we have been given the domain and we have to find the range. So for example, in this question 4a, we have been given the domain. We have been given the equation fx is equals to 5 minus 2x. Yeah? And we are told to find the range of the values of this equation if we input the value of x to be -3 up till +4. Okay. In the previous lecture, if you remember exercise 1.1, what we did normally was to just take the most minimum value, which was the input, and the most maximum value to form the range. Okay, so what is different now? You see, in the exercise 1.1, we were discussing graphs which were forming the equation y is equals to mx plus c. I do know that this one also follows that format, but I'm talking in terms of this also and this also. Okay, so please listen carefully. So mostly if we see y equals to mx plus c, it's something like this straight line, or something like this, or something like this, and it's just a straight line. There is no ups and downs, and it's constant. Okay, it has a constant gradient. It's declining, so it's declining forever. Okay, there can't be a curve in it, nor there can be a fraction in it. So that's it. So the thing is that those graphs were constant. Okay, for example, our gradient would have stayed the same over all the aspects of the graph of the line itself. For example, if I would take y is equals to 2 here and y is equals to 0 here, so the ratios of the two x values would be the same. Okay, if you understand what I'm saying. So those two ratios would be the same. However, right now we are discussing modulus graphs. And what are modulus graphs? They have ups and downs, and we don't know where that down came. For example, where is the point where the reflection is happening until we find out the vertex. Okay. So if we take the domain from -3 up till 4, we won't know at which point the graph is lower. For example, when x equals to -3, this is the point of a graph. Okay. And this is an example. Don't take it seriously. Something like that would be applicable to all equations. So it's just an example. So for example, this is -3. Okay, we input this, and we kind of find out the highest value from this. Okay, for example, I'm just giving an example, and we input this, we find out the lowest value from which is 4. Okay, and we find out the lowest value from it, and we just say, for example, if this lowest value came up to be x is equals to y is equals to you can say 2, and this came out to be y is equals to 3. So we are going to just directly say that fx is greater than equals to 2, but is lesser than equals to 3. However, this would be wrong, incorrect. And if you just concentrate on this specific graph, something like a graph we have made, this 4 value of x is not the lowest value, and if we see here, this 1 point is the lowest value. Okay, the vertex is the lowest value. So how can we find this out? In this case of equations, what we do is we have to input all the domains and see where the lowest value and the highest value comes, and that value will be input in the range of our answer. If you get my point, let me explain it again. We have to input all the values of the domain into the equation, and then from that equation we have to take the values which is the lowest and the highest. And for that, I will solve question number 4a. And if you see question number 4a, we can also just input the highest value here, -3 and 4, and find out the answer. But in order to clarify your concepts, I'm going to do it the other way that is going to be discussed in this exercise. Okay, so fx 5 minus 2. Okay, we could have done it directly, just input -3 and 4, because it follows the format y is equals to mx plus c, which means it's a straight line. Okay, so no big deal. Okay, so but still, to clarify your concepts, I'm going to solve it the other way. What we do is just directly input when x is equals to negative. It's really easy, but it's tedious, it's lengthy. Okay, so when x equals to -3, we say that fx is equals to 5 minus 2 multiplied by 3 is 6. 5 minus 6 is equals to -1. And as you can see, let me fill this up first. -3, -2, -1, 0, 1, 2, 3, 4. Just ignore these two boxes. Okay, so when x equals to -3, we have -1. Okay, similarly, we'll just my bad. I just did something. Let me erase this one. What I did wrong was I had to multiply 2 by -3. I just did it by 3. So 2 multiplied by -3 is -6, and 5 minus -6 will be equal to 5 plus 6, because minus multiplied by minus is positive. 5 plus 6 is equal to 11. So when it's -3, we have 11. Okay, when x is equals to -2, we have -2 multiplied by -2 is 4, -4. So 5 minus -4 is equal to 5 plus 4, which is positive 9. You can put that value here. When x is equals to, so now I will just make it really quick because it's just input and output, and I think you should know how to just solve. It's just addition and subtraction and multiplication. Okay, so what we do is 5 plus 2 is equals to 5, 6, 7, and x is equals to 0. We have 5 minus 2 is equals to 3. When x is equals to 1, we have, I did something wrong. I said 5 minus 2 multiplied by 0. I just have to just make this 0. 5 minus 0 is itself 5. So 5. And x is equals to 1. 5 minus 2 is equals to 3. Okay. So here we go. And x is equals to 2. 5 minus 4 is equals to 1. When x is equals to 3, 5 minus 6 is equals to -1. Okay. When x is equals to 4, we have 2 4s are 8. 5 minus 8 is equals to -3. Okay, so simple. We have the whole table here, and right now we just see the lowest value in the table. The lowest value is -3, and the highest is 11. And as you can see, it's again a proof. This was a straight line graph. And if you see the most lowest domain we input, it gave us the highest value, and the most last domain we input gives us the negative value. And let me clarify the fact that it's not important that the highest value gives the most lowest range value. This thing is because of the equation. It depends on the equation. For example, it's 5 minus 2x. Okay? If I just input a negative value in this x, this negative sign will turn positive itself. Okay? For example, I input -3. So it's 5 minus 2 multiplied by -3. So when 2 multiplied by -3 is -6. So minus multiplied by -6 will become 5 plus 6. Okay? So that will give me 11. And similarly, if I just input a positive value, this negative sign will remain negative. And if I input 8, for example, 4, let me say 5 minus 4 2s are 8. So this negative sign will still stay negative because there is no negative value being input in the x value. So 5 minus 8 will become something like 3. Okay? And in fact, it will become -3. So the thing is that it depends on the equation. And similarly, if I would have an equation which would be fx equals to 1 plus 2x, okay, that would be a whole other thing. I would input a positive value, for example 4, I will get 1 plus 8 is equals to 9. I will input a negative value, for example -3, I will get 1 plus -6, and which will give me -5. So again, it depends upon the equation. However, the ratio of the x and y values will stay the same because it's a straight line. Okay? So still we can determine the range of a function if it is a straight line by just inputting the lowest domain and the highest domain. Okay? We'll find out the range of values. Yes. Okay. So right now it's really simple. What we do is just lowest and highest value. We can say fx, because we have been told to find the range of the function of x, is greater than equals to -3, but it is lesser than equals to 11. So that's it. It's that simple. So this is for question 4a. And if we just see part B would be just as simple. I will erase this. Okay, and now the thing starts. Now I will show you the real difference between a modulus and a straight line graph. Okay, so just let me input the values real quick. -3, -2, -1, 0, 1, 2, 3, and 4. Let's let me cut down these. Okay, so for part B we have the equation gx is equals to 5 minus 2x. Okay. And now what? And this is in a modulus. That means there is a vertex, there is a reflection, and there are two intersection of lines. So in this case, it's really important that we input all the values, and I will show you in between there will be some errors. Gx, real quick, just input the values. And by the way, let me clarify the fact that all the values will be a positive value because it's in a modulus. So nx equals to negative 3. 5 minus 2 multiplied by negative 3 is negative 6. So 5 plus 6 is equals to 11. Input 11. And what we do again, the second thing we do is when x is equals to negative 2, 5 minus 2 multiplied by 2, negative 2 is positive 4. 5 plus 4 is equals to 9. Again 9 here. When x is equals to negative 1, 5 plus 2 is equals to 6. Here we go, 6. When x is equals to 0, 5 minus 0 is equals to 5. When x is equals to 1, 5 minus 2 is equals to 3. It's 3, yes. Okay, so again 3. When x is equals to 2, 5 minus 4 is equals to 1. When x is equals to 3, 5 minus 6 is equals to negative 1. And when x is equals to 4, 5, and x is equal to 4, 5 minus 4 to the 8 is equals to negative 3. Okay, so this negative 1 and negative 3 will become positive because they are trapped inside a modulus, as you can see in the equation. Okay, so what we'll say is 3, then 1, and then 3 again. Okay, now there's a problem in this graph. If you just concentrate here, we say for this set of values, we have been given the output in these form, in these set of values. Okay, and now if you see in between of this graph, we have the x is equal to 2, we have 1, and when x is equal to 3, we have 1. And that's quite weird. Now let me explain this through a graph. Let me plot a graph. And x equals to 3, when x equals to 1, y is equals to 3. I'm just forming a part of the graph. Okay, 3 and x equals to 1, y is equal to 3. When x equals to 2, y is equals to 1. And when x is equals to 3, y is equals to 1. And when x equals to 4, y is equals to 3 again. Okay, now let me make a line for this graph. And if you just see right now, this is the part of the graph. And if you see this lower part of this graph, this part, it's incorrect, especially for a modulus function. A modulus is something like if a line comes, it reflects back on the same axis. And it reflects back. We'll just leave this place. So it comes like this, reflects back up. Okay. So what's wrong in this is that there is a value between these 2 points which we are missing. Okay, that means that. And if you see between those 2 points, between 2 and 3, we have what? We have 2.5. And there are 2 concepts. This one that I'm saying between 2 values, we have 2.5. And before that, I explain this. Let me explain another thing. So these are the 2 values on this point of the graph. Okay? What we do is, if we just we say there's something here that is missing, that means we have to extend this graph. Okay? And if we extend this graph, we see we have a point between which comes when y is equal to 0. However, this is it's kind of purely graphical method and it's unreliable. What we do is normally we say what's in between of these 2 points. We are missing something. What's in between? We say between 2 and 3 there's 2.5, and we just input when x is equals to 2.5. We say what's the equation? 5 minus 2 multiplied by 2.5 in a modulus. Okay. So what happens is we say 5 minus 2.5. What's 2.5 multiplied by 2? It's 5. So 5 minus 5 in a modulus is equals to 0. And that's the thing. So we have another point in between, which means we have something at 2.5, which is 0, which needs to complete this graph. And how did I know that we have to choose a point in between? Because the graph was interrupted. Whenever the graph shape is corrupted, for example, from the base, we kind of take the average, we take the point in between to see if we are missing something. Okay? The thing is, it's why we take the point in between. Why not here? Why not here? And the thing is, we take in between because a modulus function is a reflection. Okay, and if you just see we take a point somewhere except this, it's not going to be a reflection. It's going to make a untrustworthy graph. So make a direct reflection, and in between we have 2.5, which allows us to make a good reflection. So that's the point why I took 2.5 as the value. So now we see through this graph we have the lowest value to be 0. Okay? If we just had seen this point and not notice these 2 1 values, we would have directly said that the lowest value is 1 itself. Okay? However, we now know that the lowest value is 0. So we say that gx is greater than equals to 0, but is lesser than equals to 11. And that's why I constantly remind to whatever your answer comes, check it thoroughly so that you may not mistake anything. Okay. So this is for part B. It's a little bit confusing, but still it allows us to clarify our concepts. Okay. Okay. So for part C, we have a partial equation in which only 2x is in a modulus. So we are going to solve it the same way. Input the set of domains we have been given. We have to input all the domains. Okay, for part C, we again have the set of values for the domain. Just input these values to find out what the y value or the value of the function or the range of the function is. Okay, so when x is equals to -3, we have y is equals to 5 minus 2 multiplied by 3 is 6, which will become, what will it become? 5 minus 6 is 1, minus 1. Okay, it will become minus 1 when x is equals to -2. We have 5 minus 4, which will become 1. When x is equals to -1, 5 minus 2 is equals to 3. When x is equals to 0, we have 5, just 5, we have 5. And then we have when x is equals to 1, we have 5 minus 2, which will become again 3. When x is equals to 2 again, we have what we have? We have 5 minus 4, which is equals to 1. When x is equals to 3, we have 5 minus 6 in a modulus, which is equals to -1 again. When x is equals to 4, we have 5 minus 2 to the 4, which is again 1. So this is the set of values for the given domain. Okay, so if you see right now, there are no intersections. For example, there are no double ones. It's -1 and then +1, 1, -1, 3, 5, 3, 1, -1. So this is a proper graph. Okay, so for the graph, we have this type of curves, right? Reflecting here, then reflecting back again. So if you see right now, it's a perfect modulus graph, and we can just, it's not important by the way that you make this graph, just check out the set of values and see if there is an intersection. For example, there are double fives along with each other. For example, when x equals to 0, it would have been 5, and x equals to 1, it would have been 5. Then that would have been a wrong graph, as it would not bring the exact same shape. Okay, so the thing is, check for errors in the coordinates, and if there are no errors, then just depend on the range of values you are finding. So right now we do not have any errors, and I've also drawn the graph to check it. So what we do now is just directly pick up the values. And by the way, it's not important that you make the graph. And again, if you're just more familiar with these topics and you practice a lot, you will obviously find out if there is any mistake by just looking at the coordinates. Okay? So right now, we see there is no mistake, no double fives along with each other, nothing, no other values. So what we do is just say that hx is greater than equals to -1, but it is lesser than equals to 3. And that is our answer for part C. Now let's proceed to question number 5. And what do we have for question number 5? Okay, it's somewhat a similar question. We have been given 3 equations, and we have to find the range of each of the function for the given domain of x values. So first of all, we have been given -1, 0, 1, 2, 3, 4. Okay, now let's solve this real quick and just input all these values. So fx is equal to 3 minus 2x. Input the value -1 when x equals to -1. We have 3 plus 2 is equals to 5. X is equals to 0. 3 minus 0 is equals to 3. X is equals to 1. 3 minus 2 is equals to 1. 1, 1. 3 minus 0 is 3. X equals to -1, so y is equals to 5. X is equals to 2. 3 minus 4 is equals to -1. x is equal to 3, 3 minus 6 is equal to negative 3, and x is equal to 4. So 3 minus 2 4 is 8 is equals to negative 5. Again, you could have found the values by just taking the lowest and most highest domain, because this follows the format of the y equals to mx plus c, the equation of the straight line. So, but however, just to clarify this, exercise, I am using this method. But still, for straight lines, I prefer you should only use the highest and lowest domain. Okay, it's much more easier, less time consuming. So for this value, we have fx is greater than equals to negative 5, but it is lesser than and equals to 5. Okay. For gx, we have gx is equals to 3 minus 2x in a modulus. And you know what? We're going to do a shortcut right now. The thing is, if you just concentrate 3 minus 2x, and this is partially related, it's just that it's in a modulus. So what will happen in a modulus? What does a modulus change? Well, a modulus only changes the negative value into a positive value. That means whatever the negative value for 3 minus 2x were coming will become positive, and the positive will remain positive. Okay. So right now, all the values will stay same for gx, except negative 1 will become positive 1, negative 3 will become positive 3, and negative 5 will become positive 5. Because first this equation will act up, and then on that answer the modulus will act. So just directly do it. It's more easier. It's a shortcut. Okay. So we have 5 3 1 1 3 5. Again, now if you see here, there are two ones, and I showed you previously that the graph would be forming something like this approximately. For example, it came from here, went till here, then here, and then it went up again. It would form a more, it's not a good graph. It's it's corrupted, you can say. It's wrong, because the shape is either a V shape in a modulus function we are talking about. It's a V shape, something like this. Wait a second. Something like this. And then from here we have something like this, something like a V shape. Oh, it's messing up again. So it's something like this, or something like wait a second, or something like this. Okay, it's not a direct reflection, but just to give you the idea. So it's an incorrect graph. And what I told you was the graph is coming in this way, and it's straight here, and straight here. So it's something we are missing in between. I've told you in question number 4. So what we do is we say that there's something in between, because at that point these two lines are then intersecting. So we take the point which is in between of these lines. So right now we have 1 and 2, and what's between 1 and 2? It's 1.5. So if we just input 1.5 in gx, 3 minus 2 multiplied by 1.5. So 1.5 multiplied by 2 is 3. So 3 minus 3 is equals to 0. Okay. That means the lowest value we have is 0 in this graph. So what we do again is gx is greater than equals to 0, but is lesser than equals to, what is lesser than? It's lesser than equals to 5, sorry. Okay, so that is for gx. And what's for hx? So hx is a different value. We have hx equals to 3 minus 2x, but 2x is in a modulus. Again, erase the values for the previous question. It's not the previous question, it's the same question. That's it. What we do is we say that just input these values. When x equals to negative 1, 3 minus 2 still is equals to 1. X is equals to 0. 3 minus 0 is equals to 3. X is equals to 1. 3 minus 2 is equals to 1. Just let me copy these values. So 1, 3, 1, and then oops, x is equals to 2. We have 3 minus 2 to the 4 is negative 1. So again negative 1. When x is equals to 3, we have 3 minus 6, which will become negative 3. And then similarly, we have when x is equals to 4, we have 3 minus 2 4s are 8, which will become negative 5. Just copy these values, negative 3 and 5, negative 5. Okay, so there is no such problem in this graph. Okay, so what we do right now is we take the lowest value and the highest value. The lowest value is right now negative 5, and the highest value is 1. So we say that hx is greater than equals to negative 5, but it's lesser than equals to what? It's lesser than equals to 3. Sorry. Okay. So that is for hx, this is for gx, and this is for fx. These are the three values, three equations whose range we have to find out, and we have found that out. Let's proceed to question number 6. And what do we have here? Okay, again, we have to sketch that old graph. Okay, 6a, sketch the graph of y is equals to 2x plus 4, for x is greater than -6 and x is lesser than 2, showing the coordinates of the point where the graph meets the axes. And on the same diagram, we have to sketch the graph for y equals to x plus 5. So it's a multiple diagram graph. So what we do is, first of all, find the range of values for y when we input x. So as you can see, this is a modulus, so we have to concentrate that all values should be positive. Let me do -6, -5, -4, -3, -2, -1, 0, 1, and 2. Okay. So for part 6a, we say y is equal to 2x plus 4 in a modulus. And what we do for do for that is we input the values of x. So x is equal to -6, y is equal to 2 multiplied by -6 is -12. So -12 plus 4 is -8. This will become 8 after it passes through a modulus. So x is equal to -5. 2 multiplied by -5 is -10. And if at 4 we have 6, whatever the answer is, we have 6 because it passes through the modulus. So x is equal to -4. 4 2s are 8. So -8 plus 4 is equals to 4 because it passes through a modulus. X is equal to -3, 3 to the 6. -6 plus 4 is equals to 2. X is equals to -2. We have 2 to the 4. -4 plus 4 is equals to 0 even after it passes through a modulus. X equals to -1. I know I'm sounding boring, but still has to be done. So x equals to -1. 2 multiplied by -1 plus 4. So -2 plus 4, we will get 2. X equals to 0, we will get 4 directly. X is equals to 1, we get 2 plus 4 in a modulus, which is equals to 6. 6. X equals to 2, we have 2 to the 4 plus 4 in a modulus, which is equals to 8. Okay, at last we have found the set of values, and let's quickly make a graph for these values. Okay, let me erase the previous graph. And what do we have arranged it? We have it till x and 8. We have to make the y values till 8. And let me get it up. Okay, so I've just marked the coordinates we have here. For example, -6 and 8 I've marked up here. So in the graph, I've just marked the coordinates we have just found out. And what we do is just connect these points. Connect this with a line and connect this with a line. Save it, and here we have it, the graph for part 1. It's really that simple, no big deal. On to part B, we have the question where we have to sketch the graph of y equals to x plus 5 on the same diagram. So the thing is, what you think is that we have to find the range of values for y is equals to x plus 5. You could have done something like, just take the highest value, for example, -6, found the y value for this equation for -6, and then again do the same thing for 2, and just mark those two points and make a perfectly straight line if you could. But I prefer to take all the coordinates, as that makes a really perfect line. It's like more easier. Anything for marks. So y is equals to x plus 5. So what we do right now is just directly, we can do it directly. What we say is y equals to x plus 5. We have to find -6 plus 5 is -1. -5 plus 5 is 0. -4 plus 5 is +1. -3 plus 5 is +2. -2 plus 5 is +3. -1 plus 5 is 4. 0 plus 5 is 5 itself. 1 plus 5 is 6. 5 plus 2 is 7. We have found values really quickly. Just plot this on the graph again. Let me use the freehand tool for that. 6 and 1, -6 and 1, 6 and -5 and 0. And 4 and 1. Yeah, -3 and 2. -2 and 3. Now, if you see here, while we're drawing the graph, we have an intersection here between the 2 points. If you have that too, it's a good thing. Don't be stressed about that. Let it intersect. So again, just plot these values. We have -2, -1, 4. Similarly, 0, 5. We have 1, 6, and 2, 7. 1, 6, again an intersection, 2, 7. Okay, so if we just draw a line here, we draw a line from here and up till here. Okay, I know there are two intersections and no need to worry about those. And after sketching the graph, we have finished the requirement for part B also. However, we have a part C. Instead, we have to find the equation 2x plus 4 and is equal to x plus 5. Okay, the thing is, you can have found that equation 2x plus 4 is equals to x plus 5, and then you could have opened this up to x plus 4 is equals to x plus 5, or 2x plus 4 is equals to minus x minus 5. We have done that in the previous questions. However, that's really tedious task, especially when we have already drawn the graphs. Okay, but when we say that 2x plus 4 is equals to x plus 5, we say there's an intersection. Okay, we say that these two values are just equal. We can say that, and when these two values are equal, we say that there's an intersection. This line is coming, this line is coming. The x values are same. That's why there is an intersection at this point. Okay, so how do we solve this question? Okay, we just go on the graph, see where's the intersection points. Just mark, take the freehand and just mark those two intersections. Okay, we have marked the intersection because they are two equals. Okay, now if we concentrate on this thing, we have to solve the equation 2x plus 4 is equal to x plus 5. Meaning, we are not asked the y values. We just have to solve that equation. And if we solve this whole equation, we only get the x value. We can't get the y value from here because there is no y mentioned. Okay, only the x values are mentioned. And for that, what we do is take the x values only. So if you see from this point, one x value is -3. Okay, and the other x value we are getting an intersection is 1. So that's our answer. Simple. The answer is x is equals to -3. Yes, and 1. X equals to -3, 1, and that's our answer. Solve it graphically. And okay, you don't have to do it. Let me prove this. Okay, and I'm again going to say, do not do this. Just to prove. I'm just doing this to prove you that the concept I explained it is right. So 2x plus 4, if you open the modulus, we get two values, x plus 5 or 2x plus 4 is equals to minus x minus 5. And if you do not know what I'm doing, taking two values for the modulus functions, you know what you have to do? Take the previous lectures I've made. Okay, what you do is just solve this equation. 2x minus x is equals to, take that 4 here, -4 plus 5. Okay. X is equals to -4 plus 5, what's it? 1. Okay, or 2x plus 4 is equals to minus x minus 5. So 2x plus x is equals to -4 minus 5. -4 minus 5. So 3x is equals to -9. X is equals to -9 upon 3. 3 1 is 3, 3 3 is 9. So x is equals to -3. Now again we have those two exact same values. And if you say it's such a long thing, and we have already drawn the graph, so why not take the advantage? And sometimes it also comes the question solved graphically. The equation 2x plus 4 is equal to x plus 5. And if you have done that thing, this thing, you would get a straight 0 for that. I mean, literally, because it's wrong. It has told you in the question graphically. In this scenario, okay, you can do this equals to thing. It's long, but you want your marks won't be cut. And sometimes the examiner also cuts in this forms because they say that we have given you the graph, you should have done that. So it's more better if you have drawn the graph, use that. Use the graph to your advantage. Okay, do that. Okay, so we will do question 7. Let me erase this. Okay, so on to question number 7, which tells us that fx is equal to 2x minus 6 and a modulus -3, where the values of x, or you can say the domain, is -1 up till 8. Okay, oops. Up till 8. Okay, we have to sketch the graph of y is equal to fx, and what they mean here is on the y-axis, you take the values to be what is in the what we get from fx itself. So that's what they are saying through this. So we have to sketch that graph, and for that we have to input the values. And if you see here, -1 0 1 2 3 4 5 6 7 and 8, and we have to find the outputs for these set of values. So when x is equals to -1, we will make it real quick. 2 multiplied by -1 is -2 minus 6. minus 3, which will become positive 8 minus 3, which is equals to 5. Okay, so 5 will be the first value. When x is equals to 0, we have minus 6 in a modulus, minus 3, positive 6 minus 3 is 3 itself. So here comes the 3. When x is equals to 1, so 2 minus 6 is equals to 4, and 4 minus 3 is 1. So 1 here. And x is equals to 2. 2 to the 4 minus 6 minus 3 is equals to 4 minus 6 is negative 2. Negative 2 minus 3 is positive 2 minus 3 is negative 1. So here comes a negative 1. It's squiggly line. And when x is equals to 3, we have 2 3 the 6, 6 minus 6 minus 3. So we have minus 3 itself. Minus 3 here. X is equals to 4, we have 2 4s are 8. 8 minus 6 minus 3, which will become positive 2 minus 3, which is again negative 1. That means there's a reflection at this point, by the way, because these two values are coming after one difference. So whatever, just leave this. It's going to confuse you for many of you. So similarly, for x is equals to 5, we have 2 5 to the 10 minus 6 minus 3, which will become 10 minus 6 is 4 itself, and 4 minus 3 is 1 again. When x is equals to 6, we have 6 to the 12 minus 6, which gives us 6. 6 minus 3 is 3. Again 3 here. And x is equals to 7. We have 7 to the 14 minus 6 minus 3. 14 minus 6 is equals to, what's equals to 8. 8 minus 3 is 5 again. And the last value we have, x is equals to 8. So y is equals to what's equals to 8 to the 16 minus 6 minus 3. So 10 minus 3 is positive 7. So these are the set of values we have to plot the graph for. And at the graph, let's just mark the points. So when x equals to negative 1, y is equals to 5. Equals to negative 1, y is equals to 5. When x equals to 0, y is equals to 3. And x equals to 1, y is equals to 1 again. 1, 1. And when x equals to negative x equals to 2, y is equals to negative 1. When x equals to 3, y is equals to negative 3. When x equals to 4, y is equals to negative 1. Okay, wait a second. Okay, I'm sorry, I just marked the wrong point. When x equals to 3, y is equals to x equals to 2, y is equals to negative 1. X equals to 3, y is equals to negative 3. Okay. X equals to 4, y is equals to negative 1 again. X equals to 5, y is equals to 1, if I'm not wrong. Yes. When x equals to 6, y is equals to 3 again. And when x equals to 7, y is equals to 5. And when x equals to 8, y is equals to 7. And this make a straight line which connects these points. And that's it. This is what question number 7, part A demanded from us. And that's it. Let's go to part B. And it's really easy, let me just clear the page. It's clear too much. I just need this space. Okay. So what part B asks us, that it says that we have to state the range of the function f, and we have known that the range is actually the set of output values we get from the domain. So we already have the table. That makes life easier. Let's see which, and if you see right now here, we know the graph is perfect, so there's no problem in the graph itself. So we see which one is the lowest value. The lowest value is negative 3. So we say that fx is greater than equals to negative 3, and what's the highest value? And it's lesser than equals to 5. That's it. That's what question number 7b asked us. And then they tell us that solve the equation fx is equals to 2. Okay, so what they asked us in fact what they told us in part A, that sketch the graph for y is equals to fx. That means that whatever y value we have, that represents fx itself. So that means if we see the y value to be on the graph, the y value 2, we will get the corresponding x values. And if you see right now from here to here, and this point, this point, and the other point is this point, comes when x is equals to 2. Y is equals to 2. Okay? These two are the points when y is equals to 2. And if you just find out what the x value is for the corresponding values, you will get the answer. That's it. If told us for the equation fx equals to 2, that means they're asking us the x value. And let me first solve this, and I will explain it more clearly. So this is at there are 5 boxes and 5 to that. So it's 0.2 in every box. 0.2, 0.4. Oh, by the way, I'm really sorry. 0.2 doesn't represent one box. 0.25 represents one box, and 0.25 is equals to 0.5. 0.25 is equals to 0.5. So the values are not 0.4 and 5.4. The values are actually 0.5 and 5.5. However, if I'm using a graph software and it's really accurate. However, if you use your pencil and scale, it's all right if you are getting 2 to 3 points more or less. It's no big deal if you're getting 0.34 something like that. It's not a big deal because they're rounded up. Okay, so we have these two values. However, I promise you an explanation, and that explanation is if we just input the function x here. Again, this is for explaining, for proving do not do this. Okay, do not do this. 2x minus 6 minus 3 is equal to 2. That's what it says. Fx is this equation, and input that equation, we get 2x minus 6 is equal to 2 plus 3, which is 5. And this is in a modulus. So again, 2x minus 6 is equal to 5, or 2x minus 6 is equal to negative 5. Okay. So 2x is equal to 5 plus 6, which is 11, and or 2x is equal to minus 5 plus 6, which is positive 1. So x equals to 11 upon 2, or x is equal to 1 upon 2. And if you see what is 1 upon 2, it's 0.5. What's 11 upon 2? It's 5.5. And that's your proof that what we have done is correct. Okay, so that's it for today's lecture. I know I'm extending this exercise a lot, but I'll just upload next lecture tomorrow, and we will complete it in that. I'm going to solve question number 8, and of course the challenge question, which is question number 9. Yeah, it's going to be tricky, but we'll solve it. Okay. See you in the next lecture. Thank you very much.